So, good afternoon. My name is Marta, and I'm going to be giving you a whirlwind tour of augmented reality in neurosurgery. So, our jumping off point is actually going to be talking about navigation in terms of car navigation, something that perhaps we're all more familiar with, but quite nicely parallels the evolution of image guided surgery. So, until about 20 years ago, we used maps and atlases to guide us while we were navigating around streets and cities and countries. And what this type of navigation requires is that the driver or the passenger is able to register the world that they're seeing around them, so the streets, the road signs, etc., with the physical paper map. This is quite a challenging task, as some of you might remember. About 20 years ago, GPS navigation, where the location GPS navigation became much more accessible to the common driver. So in these types of systems, the location of your car is visualized on a continuously updated map, and you're navigated towards your destination by the system telling you to turn left and turn right and so on. BMW has taken this GPS navigation one step further and allowed for an augmented reality visualization or a heads-up display. So what this means is that you're no longer looking at a separate device to get your navigation information, but that's all projected onto your windshield. So you can see where you're supposed to turn next, you can see how fast you're going, road signs that are coming up, and so on. And so you're no longer doing a mapping between a little device and what you're seeing in the outside world. So in terms of neurosurgery, until about 30 years ago, traditionally what neurosurgeons were doing was that they were looking at X-ray films, so slice views. They were trying to reconstruct the three-dimensional models from these slice views in their heads, and then project that and use that model to guide them to a particular anatomy of interest on the patient on the operating room table, whether that was a tumor or a vascular anomaly or so on. Over the last several decades, though, surgeons have moved towards image-guided surgery, which is very similar to a car's GPS. So what happens in image-guided surgery is essentially two things. One, you have a correlation between preoperative patient images and the patient, and this is obtained using registration. The other thing that's happening is that both the patient and the surgical tools are tracked. So this means when the surgeon uses a surgical tool, he can see the location of that surgical tool on the patient images of typically a workstation computer. Okay, this obviously has improved guidance, has allowed for better navigation and more minimally invasive procedures where the surgeon is getting to their anatomy of interest more quickly. What we're looking at developing in our lab is really the BMW of neuronavigation. So we're combining preoperative patient images with the real surgical scene in order to allow the surgeon to have an augmented reality view. So not only does this reduce the burden of the surgeon of mapping images from the neuronavigation system to the patient, but it also allows the surgeon to see anatomical data that's not visible below the patient surface, so the surface of the brain. This means that they can better tailor craniotomies, they can better find resection corridors to particular anatomy of interest, because this is all mapped into one image. So in terms of the work we're doing in our lab, there's several things we're studying. One is, how do we best visualize the virtual object or the preoperative patient images? So we're looking at using different cues to do that. Another thing that we're looking at is improving depth perception of AR visualization. So in augmented reality, a typical problem is that the virtual image always looks like it's floating above the real world. So we're looking at using different techniques in order to make it look like the virtual image is actually at the proper depth. We're also studying how we can visualize flow and help surgeons to differentiate between arteries and veins intraoperatively. And based on our experiences of using our system in a number of surgical cases, we found that it's quite useful at different steps taken in neurovascular surgery, whether that's on the skin to plan the craniotomy opening or during dissection in order to plan a resection corridor. So that's it. Thank you very much. That's all.